continuing with functions. I hope you do remember your functions from grade 11, because if you don't, you are in trouble. It's not going to be easy to operate in functions here in grade 12 if you don't remember your grade 11 functions. If you don't remember it, you need to go back to grade 11 and remind yourself. No one else is going to remind you, because we assume that we already know your grade 11, but then we don't have a choice. We'll just remind you along the way. All right, we have a question here, interpretation of functions. The sketch alongside shows the graph of f of x is equal to a raised to x, and it is passing through this point with coordinates 3s to 1/8. That is your f. And then I want to remind you of something there. Remember, before you start answering questions, you need to understand the question fully. You remember the mother function of this thing, right? Originally it is like this, but then when it is reflected in the y-axis, it now goes like this, right? For this one, your b is greater than 1, but for this one, your b is between 0 and 1, so it is a proper fraction, right? So for this one, your b is a proper fraction, and the b for this one then is going to be a proper fraction. And then the question continues saying, g is the reflection of f in the x-axis. There is our g, and this is our x-axis. So this was reflected to give that one. And remember, reflection in the x-axis, it changes the sign of the y. And then h is the reflection of f in the line y is equal to x. This one is telling us that h is the inverse of f, and vice versa, f is the inverse of h. So they are inverses of each other, right? Now, answering the question, determine the value of a. Determine the value of a. We have that for the question 1. How do we determine the value of a? We have that your f of x is such that y is equal to a raised to x. You cannot determine the value of a if you are still having f of x. So you have to replace f of x by this y. Now, the only reason why we were given this coordinate of p in f is so that we can determine the value of a. So we substitute the value of x and the value of y into this one. Your x there is 3, your y is 1/8, so we have 1/8 is equal to a raised to 3. And we need to solve for a here. How do we do that? We need to write both sides as exponents there, raised to 3. So this side we have to write something that is raised to 3, and this is 8. It's a perfect cube. So remember that 2 raised to 3 is equal to 8. So it means here we have 1/2, which is raised to 3. And this is going to give us 1 cubed is a 1, 2 cubed is an 8. So 1/8 can be written as 1/2 raised to 3 there. So let's do that. So this one you're going to have 1/2 raised to 3 is equal to a raised to 3. So both sides, they are raised to 3. Because both sides are raised to 3, we can conclude that the bases are equal. So we are saying your a there is equal to 1/2. So we are saying a is equal to 1/2. Therefore, your f of x is equal to 1/2 raised to x. And remember that time I said this has been reflected in the y-axis, so it's now the fraction for the a. There is our a, which is a fraction. The second question, determine the equation of g. There is our g, which is reflected in the x-axis, and we said reflection in the x-axis changes the sign of y. Let's change the sign of that y there. I'm writing y, the function of the f of x there. My f of x is y is equal to 1 over 2x. Now, g, then it follows that g should be, it is the sign of y that is changing. So it's negative y is equal to, negative y is equal to 1 over 2. This is not an equal, a negative sign. So it's 1 over 2 raised to x. This is this is the equation of f, and this is the equation of g, and the only difference between these two is the sign for the y has changed, and we cannot leave our equation with a negative y, so we divide both sides by y to have by negative 1, to have y is equal to negative 1 over 2 raised to x. So for number 2, the equation of g there, g of x is equal to negative 1 over 2, put it in brackets, is raised to x. So you see the difference between these two is just this negative. The other one is positive and the other one is negative. And then number 3, write down the range. What is range? Range, we are talking about the y values. Range, we're talking about the y values. Now, the y values for the first one, the y values for f, this is our f. And remember, this is the asymptote. F gets as close to the asymptote as possible, but it will never touch the asymptote. So it will never be equal to the asymptote. So the values of y here, it's starting from 0 going to positive infinity, but not equal to 0. So our range there, your y is greater than 0. Sorry, your y is greater than 0, and your y, remember, has to be the element of real numbers. And then for number 2, we are still talking about range, the y values. We now want the range for g, and this is our g. Our range for g is also starting from that, going downwards. Remember, range is the y values. Domain is the x values. So the range for this one, what's happening to my pen now? Oh, there we are. So we are saying the range for g is starting from here going down to negative infinity. So that is the negative values of y. So the range for this one, your y is less than 0, and it is still element of real numbers. That is number 3. Okay, this is supposed to be a 2 like this one. And then going to number 4, determine the equation of h. Where is h? This is our h, and we were told there that h is the reflection in the line y is equal to x. That means is the inverse. H is the inverse of f. Let's determine the inverse of f. Your f is y is equal to 1 over 2x. So the inverse there of f is, exchange the x and y, we have x is equal to 1 over 2, not x, 1 over 2y. Then make y the subject of the expression. Your y then is equal to log of x in base 2, not base 2, base 1 over 2. So we are saying here, the inverse of f in this question, we are calling it h. So we are saying then the equation of h is equal to log of x in base 1 over 2. Now there's something I want to explain there. Remember, remembering your exponents, this can be written as 2 raised to a negative x, right? 2 raised to a negative x. This 2, if it goes up, the exponent becomes negative. So this can be written as that. Now, the inverse, when it is written like that, it looks different. So we are saying the inverse there, we have y is equal to 2 raised to a negative x. And then to get the inverse, we exchange. So is x is equal to 2 raised to a negative y. And then make y the subject of the expression. We have negative y is equal to log of x in base 2, but we don't leave our y being negative. So we divide both sides by -1 to have negative log of x in base 2. Now, remember we said these two are the same. So it means because these two are the same, they've just been written in different ways. It follows that the inverse of this, which is this one, is exactly the same as this, because this is also the inverse of that. So you can write it this way, you can write it this way. So we can say also your h of x is equal to negative log of x in base 2. These two are the same, but for now, we just want to write it this way. Okay, that is number 4. And then number 5, write down the domain of h. There is our h. Remember, domain is the x values. And the x values for h, it is the positive side there, right? And when we say the positive side, we are saying your x is greater than 0 and is also element of real numbers there. That is your domain. Your domain, that is the x values, is only restricted to the positive side. Okay? That is number 5. And then number 6. Write down the coordinates of A, B, and C. The coordinates of A, B, and C, where are they? There is A. A is on F. Let's use F. Your F there is y is equal to 1 over 2 raised to x. And then at A, the x is 0. So we are saying y is equal to 1 over 2 raised to 0, which is equal to 1. So it means the coordinate for A is your x is 0 and your y there is 1. And then the next one is B, the reflection of A. So we are saying here for our B, we don't have to calculate that one. Remember, it's a matter of changing the sign of the y. So for this one, it's reflected in the x-axis, it becomes 0 as to a -1. We've just changed the sign of the y. Remember, that's what we did here. We just changed the sign of the y to get the equation of g. So we do the same for the coordinates also. So we are saying this coordinate has been reflected in the x-axis to give b. And that b is 0 as to -1. And then c. Where is C? There is C. C is the reflection of A. Remember, this is the intercept, the only intercept for that. And then it is reflected in the line y is equal to x to give this one. So this A here is the reflection. This C is the reflection of the A in the line y is equal to x. So when we talk about reflection in the line y is equal to x, we talk about swapping. So it means if it was 1 as to 0, here is going to be, it was 0 as to 1. Here it becomes 1 as to 0. There we are. We've just swapped the x and the y because these two are reflections of each other in the line y is equal to x. And that was B, that was 6. And then 7. Determine the coordinates of P, the image of that P. Alright, determine, the correct way of saying it is, we have a P. So determine the coordinates of the first image of P. There is the image of P, and this is the original P. And remember, for us to get this, we reflected P in the line y is equal to x. And whenever we reflect in the line y is equal to x, we exchange the x and the y. So if P was 3:1/8, then the first image of P there will have the coordinate 1/8:3. It's a matter of swapping. P was 3:8, so this has to be 1/8:3. That is the coordinate, that number 7. And then let's go to number 8. Oh, number 8 is the interesting one. Oh. All right, we'll need to use our diagram there for this one. Let me make my diagram a little bigger. There we are. Yeah, it's a little bigger. This is going to be better. All right. For which values of x is f of x greater than 1/8? Where is f of x? This is f of x, right? And we have a coordinate 1/8. This is the y. So we are saying we have a 1/8 there. 1/8. And this 1/8, we can draw a line. My line is too high, right? Let me not draw that line then. So my 1/8 is somewhere there, right? And if I'm to draw a line, there is my line for that 1/8, right? Whatever is on top is bigger than 1/8. What is below is smaller than 1/8. And it's saying here, your y, the values of x where the y for that f of x is less than 1/8, right? That those values, sorry, the values of x where y is less than 1/8, we're talking about anything that is below this line for this graph, right? So if I'm to draw it here clearly, yeah, this one is going to be better. And then I have my p here, and this is 3:1/8, and I have my 1/8 here, 1/8, and then I have a line. There's a line that goes like this, right? Yeah, it's clear now. Now, the question is saying, what part of the graph, what are the values of x for the part of this graph which is below 1/8? And that part is this one. This is the part of graph which is below 1/8. And what are the values of x for that part? We have a 3 here. Coordinate is a 3 here. So this part of the graph is represented by the values of x which are greater than 3. So we are saying the values of x here, your x is greater than 3. So when y is less than 1/8, that is under this 1/8, your x will be greater than 3. So this is the part of the graph that we are talking about, from 3 going to infinity. And then the second one. The second one, number 2. This one here is saying, I'm just replacing that g of x with a y, right? So I have -1 less than y less than 0. We are dealing with the g of x. Let me draw it here. Probably it's easier. And then my g of x is like this. And then remember the coordinate for that y-intercept. This is -1. So we also want to do this. At that -1, there is my -1 there, right? And then we are saying the values of y we are interested in here is from -1 to 0. So it's from -1 here all the way to 0. So we want the corresponding x values for these values. So the corresponding x values, starting from here, right? This is the part of the graph that we are interested in. That's the part of the graph which is between -1 and 0. Remember, this is y. That's y. And that area there is from the y-intercept, this b, because this is our b, right? So it's from 0 to that -1. And what is covered for the graph is this one there. And the values of x for this thing is from 0 going to infinity. So we are saying the corresponding values there for the corresponding values for this there is x is greater than 0. Or if you want to write it in that other notation, it's 0 less than x less than infinity, right? Those are the values of x for which g of x is between -1 and 0. That is between -1 and 0. This is our -1, this is 0, and this is the g of x that we are interested in. And the corresponding values of x for this part of the g of x is from 0 to infinity. So we are saying our x is greater than 0. And then the last question, the very last question, and then I have my weekend after that. It's, you remember this equation? It was h of x. So we are saying here the values of x for which h of x is greater or equal to 3. Where is our h of x? Where is our h of x? This is our h of x, and on our h of x, we have a coordinate. Let me redraw it. It's going to help if we redraw it. This is our h name, and then we have a coordinate here. And that coordinate, remember, we said the coordinate, therefore, for p is 1 over 8 as to 3. So our 1 over 8 for the x, 1 over 8, and then the 3 is for the y. Now it is saying the part of the graph which is greater or equal to 3. This is my 3 line. I'm going to draw it here. This is my 3 line, right? The part of this graph which is greater or equal to 3 is up there, right? So the only part of the graph which is greater or equal to 3 is this part here, which is going to infinity. But as it is going to infinity, it's not going to cross the y-axis to go that side. So the only part that we're interested in, which is greater than 3, is the one that is between 0 and 8. 0 and 1 over 8. So the inequality there is between 0 and that is our h of x. I do not want to, oh sorry, it's supposed to be x. Hey, we're looking for the values of x. So it's 0, x, and 1 over 8. We are saying this function, when it is greater or equal to 3, then the corresponding x values is from 0 to 1 over 8. There we are. I've drawn it here. This is the part we are talking about. There is our coordinate. This is our 3, which is the y value. Whatever is above that 3 is only occurring between 0 and 1 over 8. So the values of x, which correspond to that part, is from 0 to 1 over 8. That is 0 to 1 over 8. And that is all for this one.